All right, everybody, welcome to week 14 about finding angle measure. We're going to do some worked examples. These are called, just so you know, they're called worked examples. And what is that? That is me doing an example from each topic. Okay. And this will free us up in class, as you already know, to do more tasks like we did today, the palindrome task, and try to apply math. So, but it's easier when we just talk about the nuts and bolts in a video like this, right? So let's get started. Find the angles in triangles. Okay, so if you were to cut out the three angles in this triangle, like that, and that, and that, and then you line them up so that, let's take this top, this 21 degree, and let's put it up like this. And then the 125, that's like a obtuse angle, so just like that. And then this X angle, okay, so this is not working out so well. This X angle is actually like there. Let's say this is X. This is the 125. And this is 21. They're supposed to make a straight line. So if I take these angles and cut them, yeah, I mean, you should really do this. Make a triangle, cut out the angles, and then shape them. And then you will find that their bottoms form a straight line. And do you know what the measure of a straight line is? I'm sure you know that the measure of a circle is 360, right? 360. Well, then that means line, there we go, is 180, right? 180. So that means that three angles in a triangle, if they form a line, they add up to 180. So we can just do 21 plus 125 plus X equals 180. And then, we can just figure it out. So these two add together to 146 plus X equals 180. Inverse operations. And what would that be? 34? Is that 34? Let's see. I did my math right. All right, it's 34. So pretty simple. It's called the triangle sum theorem. Let's just write that down. Triangle sum theorem. All three angles in a triangle add to 180 degrees. But it might seem like, okay, is that important? It is important because then we can find missing angles and that will help us. Like here. All right. So, well, this is another type of angle pair. So there's lots of angle pair relationships in geometry. And so the triangle angles is one, but then these, I want you to draw this figure and know it. It's called parallel lines cut by a transversal. So transversal means, trans means to cross, versal means, what does versal mean? I don't know. But this is the transversal here. This guy. Cutting across the two parallel lines. And these are the symbol for parallel. And so that's what that means. Okay, so we have our two parallel lines, and then we have A and B, our angles formed within the transversal and the parallels, right? Now we actually have other angles here. They're not all labeled. If you count them, you should count 8, right? Well, what do you think is the relationship between A and B? You might say, I don't know, or you might say they're congruent, they're the same. You might say they're both acute. So these angles have a special name. They are called alternate interior angles, alternate exterior angles, and they are congruent. Okay, so because they're congruent, so we can write angle A is congruent to angle B. They are alternate exterior angles. And so we can set up the equation 5x minus 15 equals 2x plus 21. And then we put our variables on the left, put that number on the right. 21 plus 15, which would be 36. So 3x equals 36 divided by 3. Oh my. And then what does x equal? Oh my. It is 12. So x is 12. But we want to know angle B. We don't want to know x. We want to know angle B. Angle B is 2x plus 21. So we got to do 2 times 12 plus 21. Substitute our x value in, which is 24 plus 21, which would be 45. 45. But I have more to say, so don't go away. So that means that this angle is 45. And this angle is 45. But what would the other angle here be? Do you know? Well, we see a straight line again, like we talked about in the last problem. So that would have to be 135, so that they add to 180, right? And so that's 135, and this is 135. Oh my. This one would be 135. This one would be 45. This one would be 135. And this one would be 45. So you see there's two different numbers that they can be. And you should notice some different relationships, the ones across from each other and then the ones adjacent to each other. So I want you to look up and come to class with the definition of vertical angles, linear pairs, adjacent angles, supplementary angles, complementary angles, corresponding angles, alternate interior, exterior, and the last is same side interior, exterior. So it's a lot of work, but if you could do that, that would be great. And if you know them, then it will make these types of problems a cinch. All right, and so we are now moving on to these types of problems. So this is the same equations, but now we have some new symbols. So this symbol means, what does that symbol mean? Do you know? Perpendicular, which means 90-degree intersection. Now, if you look around wherever you are, it doesn't even really matter where you are. I am sure you will see right angles all over the place. Right angles are so important in design, in building, in life, okay? The carpet here on the floor has right angles in 4 corners. So it's important to know when angles are right. And so here we have a right angle, okay? And QPR is this angle right here. So, it goes from Q to P to R. So it goes from one side, this is called the vertex, to the other side. So I'm going to write 7x minus 9 on the inside. And then I will change color for RPS. RPS is right there, and that is 4x plus 22. And so those are, I like to call it like, we got part 1, we got part 2, and we got the whole thing. Okay, so there's another postulate called the angle addition postulate. Now I'm just realizing the first thing I told you was a theorem. Okay, so this is another form of a conjecture called a postulate. Just means you don't have to prove it. Don't worry about that for now. Just going to tell you what it is. Angle. So how should we say it? Part 1 plus part 2 equals the whole angle. Now I'm going to go back. Don't write that down yet. Adjacent part 1 plus adjacent angle formed from opposite sides, or from non-common side. All right, so there we go. It's the angle addition postulate. So we have angle 1 and angle 2, and then they have an adjacent side, PR, and then they have their non-common sides, QP and PS, which makes angle QPS, which is a right angle. So we know that we can write it like this: QPR plus RPS, those two small angles are equals the whole thing, QPS. So follow those letters, see where that is. And so now we can substitute. So QPR is 7x minus 9 plus 4x plus 22, and it equals QPS, which is 90. And so now we just, we got our 11x, combine those like terms. 22 minus 9 is 13. It was 90. Put my put that 13 on the other side. What is 90 minus 13? It is 77. That's good. 77. Which makes x, what does that make x? It makes x 7, right? But we don't want to know x, we want to know QPR. It says find QPR. So looking back, that's 7x minus 9, which implies there's 7 times 7 minus 9, which is 49 minus 9. Aha, it's falling right into my lap here. 40. Boom. So is it 40? It's 40. All right. So it's a lot of really new stuff probably, but good stuff. And wow, this one was the really tough one, and this one is super simple. So once you look up those angle pair names, you'll see that these are alternate exterior, so they're the same. Yeah, I just want to show you, like, once you know the angle pair names. Now these are corresponding angles, they're the same. These are alternate interior angles, they're the same. They're not all the same though. These are same side exterior angles. They're not the same, they are supplementary. So know those angle pairs, and then you'll know whether they're congruent or supplementary. It'd be super simple. So that's not week 14. That's the section 14 here. Welcome to the geometry unit. I hope you enjoy it. Geometry is like my favorite math, although all math is cool. And then the last thing that you have to do this week is our numbers and operations quiz 3, which we did numbers and operations way at the beginning of the year. So quiz 3, we even did that. So that's going to be the exponents, back to the exponents. So I hope you have a great time doing all this check for understanding work, and I will see you in class.